Unit 6, Lesson 3. We are going to be working with similar figures and proportions. There's kind of a saying, there's a saying called CPCTC, corresponding parts of congruent triangles are congruent. And this is kind of a play off of that, of CPSFP, where we have the corresponding parts of similar figures are proportionate. The CPSFP, corresponding parts of similar figures are proportionate. So if I dig into this first example, okay, I have triangle RST and I have triangle XYZ. Now again, the order matters. So this first letter corresponds to the first letter over here. The second letter corresponds to the second letter over here. And the third letter corresponds. So again, how that kind of goes, it does matter. So the first part is we want to identify the ratios of corresponding sides. So again, RS is going to be corresponding to XY because they're the first two letters next to each other. So I'm going to put my big triangle on top. I'm going to put my small triangle on the bottom just to start. Again, I'm just picking one. So I'm going to say, all right, I have RS over XY, and RS is 20 and XY is 12. Oops. So if I see that, okay, and so that's kind of my proportion, okay? Well, let's say that I want to look at maybe, what about ST? Well, ST is going to be corresponding to SY. So ST is, again, my big triangle over YX or YZ, which is in my small triangle. And so ST is 30 and YZ is 18. Now I'm going to go through and simplify these so that I can compare them. I know that these have 4 in common, so divide by 4. I'm going to get 3 over 5. And if I divide this one by 3, I get 10 over 6. And then I'm going to divide it by 2. I should have divided it by 6. But I am going to get the same ratio. So that's good. So that means that they are similar. And we're just going to, since we're doing it, we're going to do the other side as well. So again, it's going to be RT is going to be similar to XZ. So RT is similar to XZ. 25 over 15. Divide by 5, I get 5/3. So we're good there. So because all sides have a ratio of 5/3, we could say that it's corresponding. Now, remember, that was with me going big triangle on top, small triangle on the bottom. I could write it as the small triangle on the top and the big triangle on the bottom, which again, thinking about if I flip-flopped all of these, that would give me a ratio of 3/5 because I'm flipping my numerator and my denominator. And so that's what we're going to use for our scale factor, because if we look, RST is my big triangle, so I'm going from big to small, which means my scale factor has to be less than 1. And again, if we think about that, that makes sense because scale factor is to be less than 1. It makes sense because anytime I multiply a number by 1, I get the same thing. If I multiply it by a number that's smaller than 1, I get a smaller number. And if I multiply by a number that's bigger than 1, I get a bigger number. So if our ratio was small to big, we would use a scale factor greater than 1. So again, if I look at this, triangle RST is my big triangle, triangle XYZ is my small triangle, so I need to use a scale factor of 0.6. So my answer, my scale factor is 0.6, which means if I take 30 multiplied by 0.6 or 3/5, I'm going to get 18. If I take 25 and I multiply it by 0.6, I'm going to get 15. And if I take 20 and I multiply it by 0.6, I should get 12. So that's the power of a scale factor, is we can then just multiply corresponding sides to get our new number. All right, so we're going to go a little bit faster on this one. What is the scale factor of, again, QRST? So that's my small triangle, to ABCD, which is my large. So I'm going to go small to big. So again, my scale factor is going to be bigger than 1. And so if I look, this goes 6 to 12. This goes 4 to X. This one goes 8 to 16. Okay, well, right now I know 6 to 12, I can multiply by 2. 8 times 2 is 16, and 5 times 2 is 10. So 5 times 2 is 10. So I know that my scale factor is going to equal 2. So find the value of X. Hint, use a proportion. Okay, so I'm going to pick two sides that I know. And again, I'm going to go small over big. So I'm going to say, okay, I know that 6 corresponds with 12 equals, well, I know 4 corresponds with X. Now it's just cross multiply. 6 times X, 6X, 12 times 4, 48. Separate your left and your right side, divide by 6. X equals, what would that be? 8? Now, you could use the scale factor. You could say 6 times 2 is 12, 4 times 2 is 8. So, again, multiple ways to solve this. It did say use a proportion, which is why I did it this way. The ratio of lengths is in similar polygons is the same as the scale factor. Okay, so a town is building a new swimming pool. An Olympic pool is a rectangular with length of 50 meters and a width of 25 meters. The new pool will be similar in shape, but only 40 meters long. So find the scale factor. Okay, so again, we're gonna have a slightly smaller one. It's gonna look something like this. This is gonna be 40. We don't know what this is yet. But again, we can go, so again, we're gonna go from our big to small. We're starting with this big pool, and then we're going to a smaller pool. So I can use 50 and 40 to come up with a scale factor. So, but because I need to multiply it by a number that's smaller, I'm gonna put this one on first. So I'm gonna say 40 over 50. I can simplify that to 4/5. So my scale factor is 4/5 or 0.8. Find the perimeter of an Olympic pool and the new pool. Okay, well, the perimeter of this one's pretty easy. So the perimeter of the Olympic, I already have all the numbers. Perimeter Olympic. Again, 50, 50, 25, 25, 150, and that's going to be meters. Got to figure out X. So what I'm going to do is I'm going to take my number from my original, could use a proportion. I'm going to use the scale factor, and I'm going to say 25 multiplied by 0.8 equals 20. So this number is going to equal 20, which means the perimeter is 20 over here and 40. So 40, 80, 120. So we found the perimeter of the two pools. Find the perimeter of ABCDE. ABCDE. Okay. I don't have all of the numbers yet, but I've got two numbers that I can work with. I know that AB corresponds with FG, and that's all I needed to set up. So I'm going to say, all right, I've got 10 over 15 equals, let's see here. Let's call this Y, Z. We already have an X. Let's call this H. So 10 over 15, I'm going to come back to this formula and use it for everything. 10 over 15 equals Y over 9. Cross multiply, divide by 15. So 10 times 9 divided by 15, and this answer is going to equal 6. Different color, same proportion. 10 over 15 equals Z over 12. 12 times 10 divided by 15. And again, I am cross multiplying. You need to know how to do that. I got 8 here, which makes sense. If this was 9, that this one's going to be a little bigger. Different color. 10 over 15 equals H over 15. Okay, well, that's okay. I don't even need to do this. If this side's 15 and this side's 15 and this side is 10, this side also has to be 10. And my last one is going to be 10 over 15 equals X over 18. 18 times 10 divided by 15, and you get an answer of 12. So now we got to answer the problem. Perimeter is going to equal 10 plus 6 plus 8 plus 10 plus 12. Let's see here. I've got 20, 30, 40, 46. P equals 46. We don't really have units. Oh yeah, this symbol right here, this one squiggly line means similar. This is the symbol for similar. Last one, okay. Triangle TPR is similar to triangle XPZ. Is similar to XPZ. Find the length of the altitude PS. Okay, so again, all of the sides are going to be similar. So if this one is going to be similar to over here, PY is going to be similar to PS. So what I need to use, again, use what we know. We've got this side here is 8. We've got this side here is 6. We've got this side here is 20, and we can call this X. So I'm going to say, again, I'm going to go yellow to orange. 6 over 8 equals X over 20. 20 times 8 equals, 20 times 6 equals 8X. Separate it. 20 times 6 is 120. So 120 equals 8X. Divide by 8. And you get X equals 15. So the length, the length of PS equals 15. Using similar figures, similar shapes.